we'll get rolling.
Well, I guess it's my pleasure to, introduce Dr. Elina Nino. When I think of queens, I think of Elina because, you have taught me so much about queens. The best class I ever had was on queen rearing. And you've been up here and talked about the genetic diversities, and I know you've worked with Dr. Sue Colby, and you know how to do all the fine techniques of grafting, inseminating, and thank you very much for being here. I think that Hank has done a little more research into your background, so if anybody wants to know. And I also want to thank Dr. Elina Nino for starting camp.
Janine, if I might add, Dr. Nino is associate professor at UC Davis. She's in charge of the Bee Lab. She has her bachelor's degree from Cornell University, her master's degree from North Carolina State University, and her PhD doctorate degree from the Pennsylvania State University. And Dr. Nino, you might want to tell me, what was your thesis for the PhD? I already forgot, but you wrote an interesting thesis about bee mating, I understand.
Yes. So I did some work on regulation and factors that are affecting post-mating changes in queens. So what is driving the changes in pheromone production, ovary activation, molecular changes, longevity. So a lot of stuff related to queens.
Well, welcome.
Thank you. Thank you for the introduction. Thank you for having me. And here we are, we're going to be talking about queens. I just want to make sure that everybody can see my screen. So hopefully just raise your thumbs up if you can see it. I'm sharing it. We're good. It's the one that I have the little cursor running around, floating around. So we're good. Okay, perfect. So it is always fun for me to talk about queens. Again, that is the work that I've done when I was working on my PhD dissertation, also a little bit of work for my postdoctoral position at Penn State as well. And then I started off by doing some queen work when I arrived here in California, but it quickly transitioned into a little bit of everything because the position requires me to do really whatever the beekeepers need us to do in terms of research and need us to deal with in terms of research and explore. And of course, when I first arrived and asked everybody, so what would you like me to work on? What did everybody say? Varroa mites, right? So it has been a lot of work with varroa mites, and then nutrition, of course, some more recent work in pollination in almonds, so a variety of different things that we work on in the lab. And queens, again, still remain some of my favorite subjects. And I do have a student right now working on evaluating different types of stocks for using them in Northern California climate. When I say Northern California, I mean here around Davis. So a little bit different than what you have up further north. But she's working on evaluating those stocks, and she's actually about ready to submit the manuscript. So I'm not going to share really much of the data today with you and everything that we do in the lab, but I just wanted to give you a brief overview. And I actually wanted to start off by giving you, and let's see, there we go, giving you a couple of books that I really like that I've read, and they all deal with queens, queen mating, queen reproduction. Some of them talk about breeding, so bee breeding. Queen rearing is not the same as bee breeding, right? Just because you're producing queens doesn't mean that you're selecting different stocks. But I think these are really nice overview. These give you a really nice overview, and they're easy reads of what happens when the queens are developing, when they're mating, when they start reproduction. Really a great bit of couple of books. And then, of course, this book is the one that it's probably the first one that I've read about queen rearing and bee breeding, and it's written by Dr. Harry Laidlaw and Rob Page. And the reason why I really like this book, of course, for those of you who don't know, is that here at UC Davis, the bee biology facility where we work is actually titled or named after Dr. Laidlaw. So it is the Harry H. Laidlaw Jr. Honeybee Research Facility. It's a mouthful, of course, so we just lovingly call it either Laidlaw Facility or Bee Bio. And this is Dr. Laidlaw. I don't know if any of you have had an opportunity to meet him. He passed away back in 2003, but he is considered to be the father of honeybee genetics. So he has really a great legacy that he has left behind. And he is one of the first researchers, one of the first beekeepers who was able to successfully inseminate the queen. What he discovered was that there's a little flap that is sitting over the intro or entrance into the reproductive tract of the queen. And he figured out that you need to lift that flap a little bit so you can have a more successful instrumental insemination. And there is he's written a book. I can't remember. I have a pile of books here. I don't think I have it here with me, but he has written a book about instrumental insemination, of course, of the honeybee queen, and it has some really nice diagrams as well. And then sitting next to him is Rob Page. So Dr. Rob Page, he's also done quite a bit of work with sort of reproduction, evolution of this social behavior, and the fact that the queens lay eggs and then the workers actually take care of them. And he's the one who also had here in Davis these high pollen hoarding lines and low pollen hoarding lines. So he's done quite a bit of work as well with breeding. He has also been involved more recently, I would say, in selecting bees specifically for production of royal jelly. And he's done some of that work in China. He was a student of Dr. Laidlaw's and then later a colleague, and both of them, of course, have done work here at UC Davis. So there's quite a bit of legacy, as I said, in terms of queen rearing, breeding, and as you mentioned already, Sue Kobe was here at UC Davis. Oh goodness, several years ago now, and she's at Washington State University, but she's slowly planning her retirement, I think. And she's done a lot of work on breeding. Specifically, she's interested in breeding the New World Carniolan stock of bees, right? So again, quite a bit of legacy. And I think she was the person that I've taken my first instrumental insemination class with. So lots of fun stuff that happened and is still happening at the Laidlaw facility. And this is sort of a more current lineup of folks who are associated with the program. We have a number of staff positions. This is Joe Tauser, and he is our current facility and also facility manager and a beekeeper. And he comes from a long line of beekeepers. I think there are at least a couple of generations of beekeepers in the community. Dr. Christine Casey is the UC Davis Bee Garden Manager. So if you have an opportunity to come down here to UC Davis, I would highly recommend you visit the Bee Garden here. And it's right next to our facility. It has pollinator supportive plants, about 200 to 250 different plants. And they're also pollen producing, nectar producing, and water tolerant. So most of them are California natives, lots of good information there. And Rob and Matt are actually members of the Bee Informed Partnership team. I don't know how familiar you are with them. I'm sure most of you here are familiar with, or at least have heard about BIP at some point. And the reason probably being because they are the nonprofit organization that sends out the annual beekeeper survey, which actually just came out in April 1st. I think normally they send it out April 1st. So if you have an opportunity to fill that survey out, I know that you would that they would appreciate it. But they serve a number of different beekeepers, mostly commercial beekeepers. It's a fee for, or service for a fee, and they will go into apiaries, into the colonies. They will collect samples. They will look at the colonies, send the samples off for evaluation of varroa mites, viruses, pesticides. They will also do hygienic behavior testing on colonies if you're doing any type of selection and breeding. And Wendy and Keon, some of you here who are in the Master Beekeeper Program are already familiar or very familiar with Wendy and Keon, and they are the Master Beekeeper Program co-managers. They're really awesome, and without them, we probably wouldn't have a program anymore, because there's only so much time in the day that I can use to do the work. Graduate students, I have a few of those. They're in various stages. Lauren has been with me for about 3 years now, and she's the one who has done quite a bit of work on evaluating different queen stocks or bee stocks. Eliza is working with USDA program, and she's looking at, actually, she has an interesting project. She's looking to establish if there's a chemical that they found sort of by accident almost, that it might support queen longevity. So she's working on that piece. She's a master student. And then Richard is just starting in the fall actually with us, but he's been a staff member for a while now, and he's been doing some interesting work with assessing different phytochemicals as nutrient additives on success and health and productivity of the colonies. So he's going to continue on some of that work. And Carrie is really an excellent undergraduate student and a helper, and she's been working closely with Lauren. In addition to what we have in terms of people in the UC Davis facility, and of course, we again all are working towards better understanding these different factors that are impacting colony health. So our big 4 Ps, right? The pests, the pathogens, your pesticide exposure, and then poor nutrition. In addition to UC Davis staff, we also have members of the USDA Bee Lab at Davis. We collaborate quite closely. I particularly work quite a bit with Dr. Arthi Seshadri, and she is really interested in the nutrition of the bees and nutritional impact on colony health. And Dr. Julia Fine is also interested, again, in queen health. She's also looking at the effect of different pesticides and agrochemicals on queen health and overall colony health as well. And I think actually her lab was in part associated, or not associated, but at least has done a little bit of work on evaluating the new newly approved, conditionally approved vaccine for honeybees, right? So I'm sure all of you have heard of the vaccine that was recently approved by USDA for use for control of American foul brood. So, and of course, if you have any questions as we go along, type them in the chat or write them down and we can answer those questions at the end. But what we really are here about are queens. And I was asked to present a little bit about queens, particularly some issues with the queens, what to look for if you're thinking about potentially requeening your queens, and then of course the process of the queen introduction, which could sound intimidating, especially if you are a newer beekeeper and you've never done it before. Okay, so quick recap for those of you, again, who might be a little bit newer to beekeeping. And just since we're thinking about bees, or since we're thinking about queens, just to give you an overview of their development and quick biology, right, of the queens. Of course, we have drones, workers, and queens inside the colony. Some people argue those are the 3 castes. Others will say that we have 2 castes within the female group, right? So really there's no consensus, I would say, from what I've seen in literature. But the point is we have our beautiful queens here, right? And if the colony needs a new queen, right, or if they're preparing for swarming and supersedure, etc., they will start producing queen cells, right? So they will start producing and building queen cells. And those queens, those female larvae that come from fertilized eggs will take 16 days from egg laying until the adult emergence. right? So it takes the shortest amount of time, and it probably is because the queen is
I get a couple
essential
of Tylenol.
for the colony reproduction and for the colony success.
How about your regular nightly pills?
Could do those.
So I think
I could do
there are
those.
some folks have unmuted microphones, so if you don't mind just muting them so we can,
Any Tylenols or in the other room and the other thing?
or we can keep going. I'm going to keep it. Thank you, John. Okay, so the female larvae, am I muted still? Oh, somebody muted me.
You're good.
Are we
You're
good?
good.
Can you hear
They
me?
muted everybody else, but you're back on.
Okay, good. Thank you. I wasn't sure. It just popped up on the screen. Okay, great. Thank you. So the female larvae are the ones that are hatched from fertilized eggs, right? And they essentially can become either queens or workers. And that determination, basically, they're all equal, if you will, and they're fed all the same food for approximately about the first 2 to 3 days. I think the early day 3 is when the food starts being switched from that royal jelly, if they're not going to become queens, into brood food. And also important thing to note is this is particularly useful to remember if you're doing any of your own queen production and queen rearing. The older larvae can actually produce and will produce lower quality queens. And this is work that's been done in Dr. Dave Tarpey's lab for a while now. He's been working on this, and the older larvae again will produce lower quality queens. So you want to make sure that if you are manipulating the queens, you get those really young larvae. And basically this differentiation is driven by nutrition that is provided to these female larvae, right? So the queens are fed royal jelly, which are the glandular secretion that contain lots of sugar, protein, and lipids. And this sugar actually stimulates excessive eating, essentially, which drives in part the transition of a female larvae into a queen. And then on the flip side of that, we have workers who now have glandular secretion mixed with pollen and honey that are fed to them. And these glandular secretion composition of these also varies between queens and workers, right? So there's a lot of extra detail that we can go into, but we're not going to do that here. Okay. Go. So I also wanted to just give you an overview of the difference in the development, right? It drives the differences in the end between the adult workers and queens. So there's a reason why the development is different, right? And in the end, we end up with queens and workers that have different anatomy, and the point of that is that they do have different roles in the colony as well, right? So for example, if you're thinking of a queen, of course is responsible for reproduction of all of the other female worker force, and they have anywhere between 100 to 180 or so ovarioles per ovary. So they have quite a few ovarioles within the queen, right? And those are essentially these little sausage-like tubules where the eggs are produced in the ovary, right? The queens have the spermatheca where they store the sperm after they mate. The workers actually cannot mate and they don't have the spermatheca. Pollen basket is present in workers, of course, because the queens don't go out and forage. It's the workers that do that. Queens do not have a barbed stinger, and workers do. And somebody usually reminds me that, yes, the queens have a barbed stinger. It's a very finely barbed. The point is, once the queen stings you, she can actually retract that stinger. The barbs do not make the stinger stay inside your skin, right? The queen can retract the stinger and she can sting you multiple times. And of course, there are differences in glands as well. And this is important because the queen, in addition to producing all of the worker force and the female workforce inside the colony, and of course, drones early in the spring, she also has a role of producing a slew of pheromones that are used for communication with the workers, and they sort of regulate the social organization of the hive. Most of those pheromones that we know most about are produced from mandibular glands and a couple of other glands that I'll actually mention in a bit. And of course, workers also have, as I already mentioned, different behavioral roles later on. Unlike queens, right? They do not reproduce unless there's a failure of a queen. What they do is they do all of the in-hive tasks, including taking care of the brood and taking care of the queen, and then foraging after a little bit, right? So when are new queens produced under natural conditions inside the colony? Right? Hopefully most of you here are familiar with that. Well, colony reproduces by a natural process of swarming. And when the colonies are about ready to swarm, the colony will produce new queens, right? So the old queen will go off with the swarm, and the new queen is going to stay in the colony, the original colony, and they will now have two colonies, right? In addition to that, the queens or the workers can determine that the queen is failing, possibly by the lack of worker brood in the colony or by changes in her pheromone production as well. They're very, very sensitive to the pheromone production of the queen, and they can remove her themselves, and that is called supersedure. Right? So when the queen is failing and the workers remove her, it is called supersedure. And of course, they will rear new queens in an emergency situation when the current queen is lost. And that could be to a number of things. It could be due to a beekeeper not seeing the queen and smushing her. And I've done it myself, carelessly putting back the lid on top of the hive. And I come back next time to check the colony, open up the hive, and on the lid, there's a smushed queen. So number of things, we've all made mistakes, right? And that prompts the workers to start rearing these emergency cells. And of course, they will rear queens and queen cells when beekeepers essentially make them. If you are aspiring to become a queen producer, or you just want to rear a few queens for your own use or even for your club use, you would consider having the workers, of course, rear the new queens. And there's an entire process as to how that can be done. And this is the class that Janine mentioned earlier, the queen rearing short course techniques. So we teach stuff other than grafting in it if anybody is scared. So why would you rear queens, right? If your beekeeper decides to rear queens, there are a number of reasons. Again, maybe you want to simply increase the number of colonies that you want to have, right? But you need queens, and you don't want the queens, or you don't want the colonies to produce those queens on their own, because we do have some research showing that these emergency queen cells might be of slightly lower quality than purposely reared queens, right? And those that are reared during swarming. Sometimes beekeeper will decide, and this is actually what is starting to happen more and more commonly, beekeepers will simply just requeen once a year, sometimes even twice a year, because they feel like their queens are actually not performing as well, and preemptively they will requeen colonies. Now, that's not always the case, but again, a lot of the beekeepers will end up doing that, and that's also more common, a little bit more common for those high-producing commercial colonies. This could be a value-added product essentially to your operation if you have good quality breeder queens that you can use to produce your queens that you can sell. Queens, I think, cost about $25 to $30 if you're selling them as a business, right? So it could be a little bit of extra income, but of course you need to know what you're doing and producing, and making sure that you produce enough to meet the demand of your customers can be stressful. You could be producing queens for improving your stock to improve the traits in your colonies, or just keeping your favorite lines going. So I mentioned Lauren, for example, is produced or evaluating these different stocks, and she has one queen that she really likes that I guess the queen has survived now for 2 years. So she really wants to rear queens, new queens from that colony. So she has her favorite, right? She's going to try and do some rearing. Again, self-sufficiency and self-sustainability is a no-brainer. Again, queens cost money, right? And then you can also do royal jelly production for harvest. Folks will sell royal jelly, right, as a supplement, similar to what is sold in health food stores like pollen and propolis, for example. There is a little bit of research showing that royal jelly can help with anti-inflammatory responses. So, for example, with arthritis, and this is a study I think that came from Slovenia a little while back. So there's some research ongoing about a health food or health honeybee products, but that could be something that you could do on the side. Definitely need to be careful with that as well, because you could be having diseases, pesticides, a bunch of other stuff. So we're not going to go into it, but that's a potential option as well. Okay, so now we have this queen that has developed for 16 days. She emerges from her queen cell, and I have a nice little video of queen cell or a queen emerging from a queen cell that we'll take a look at. Virgin queens, when they emerge, if they emerge first, will go around and they will actually search out other queen cells and sting them. So they're getting rid of their competitors, right? And workers will also call queen cells as they go along. They decide that the queen might not be good quality and they will call them. If again, these multiple queens emerge together, so multiple virgin queens emerge together, they can fight. So there is some research done on queen duels, right? It's essentially until one dies, and workers usually tend to sort of choose sides and help the preferred queen. And that single virgin queen that survives, she will go out and mate, and she will mate with many, many drones, usually within the first week. And if you have a queen that passes about 2 weeks and she hasn't mated yet, she will either start egg laying. Sometimes they can start egg laying earlier, or if she ends up getting mated, she might not be mated properly because it just physiologically does not, that's not the proper timeline, right? So here's a little video, and sometimes I have to play around with Zoom if it doesn't, it doesn't work always, the video that's embedded, but don't worry, I've done it so many times, now I know to expect it. I have to re-embed it. So this is the little video of I don't know why it's not, let's see if we can make it bigger. Oh, that's okay, we will just make do with what we have. But here's the little video of an emerging queen, and I love watching this video because it just, so she has cut out this little flap, right, and now she is emerging from her cell, and clearly these are the cells that we've made, so we grafted them. So the queen really carefully, very carefully coming out of the colony, out of the cell, and then we're going to speed it up. You can see she's not sclerotized. Her cuticle is still fairly light colored, right? And there she goes. So here's your virgin queen, right? And then I already mentioned some of these queen duels that can ensue, right? So these queen duels will happen inside the colony. This is staged. I always joke around and I say maybe my joke is stale now and it doesn't incite laughter like it used to be, because I'm dealing with a lot of younger people now, but it's like WWE, right? It's staged. It's this particular case, it's not real, but essentially you will see they will sting each other, they will bite each other until one queen prevails, and presumably that stronger, bigger queen is the better queen anyway. So, okay. So one of the questions that I have been getting more recently by beekeepers is, especially if they're, again, newer to beekeeping and newer to rearing queens, is how can I tell, or can I tell if my queen is a virgin queen or if she's mated, other than the fact that mated queens obviously lay eggs, right? So virgin queens will be slim, right? They were very slim. They are very flighty. They move really fast and radically over the frame. And there is really no retinue around those queens. So the workers do not form that circle around the queen, and they don't necessarily lick her and antenate her, right? They will take care of her, but their retinue is not going to be as strong. And then the mated queens will be larger because those ovaries are now bigger, right? So the abdomen is filled with the ovaries, it's large, they move slowly and fairly predictably and very meticulously. They will check the cells and see if those cells are clean, of the right size, right? If they're gonna lay a worker or a drone egg, and the retinue is present. So you will see clearly when I show you the video, you will clearly see that there's a retinue of workers, or the court of the queen, and they will surround her, lick her, and antenate her. So let's see the virgin queen here first, and she's almost so easy to miss if you don't pay attention, right, in the colonies. So there she is. You'll see her. She's very, very erratic in her movements, right? And it's really easy to lose her. She's very quick. She moves on the frame fast. One or two workers might follow her, but there's really no retinue, as we know that happens with the mated queens, right? And then we have a stark difference, I would say, between the virgin and here's the mated queen. So we have the mated queen. She's very calm, simply sitting there on the frame. She's going around checking to see if there's an empty cell. You'll see a lot of them are filled with nectar, but she's looking for the empty ones. And then you'll see that nice retinue of bees surrounding her, right? They're workers. They're licking her, they're antenating her, and then they're picking up the pheromone and they're transmitting that pheromone to other bees in the colony, right? So hopefully nobody gets seasick and motion sickness from me moving these frames, but I think the videos are worth seeing. Okay, so that's a little bit of a background on the queens. So we'll talk a little bit about, and you really can't talk about what are the issues potentially with the queens, right? Unless you know a little bit about them and a little bit about their development and mating and general biology. So the queen, when she goes out and mates, she will mate with dozens of drones, right? So she will mate with dozens of drones, and the most recent research shows that she can mate with upwards of 77 drones. We used to say 12 to 14 was an average, but more recent studies showed that they can mate with upwards of 70. I think the highest number was 77 drones. And there are actually benefits to this, to mating multiply and to having these multiple petrolines in the colony. Because we now know that those colonies that have multiply mated queens have increased disease resistance. I think this is in particularly true with the American fowl brood. Increased colony productivity and fitness overall, increased signal production by foragers, which actually improves the foraging, right, and success of finding and obtaining those food resources. Increased diversity of gut microbiome, improved homeostasis of the colony, right, including the reduced chance of inbreeding consequences. And we'll talk a little bit about those inbreeding consequences in a second, right? So it's really important for the queen to be mated properly. And if she's not mated properly, we can start seeing issues in the colony. And those are the cases where you might want to requeen your colony. Right? So the issues with the queen quality can stem from basically a number of different things, but a common one could be suboptimal mating. And this is something that I have actually seen in Pennsylvania quite a bit, and we hopefully are not going to be seeing it, but who knows? With the weather that we're having now, it could be that we're going to be having issues. And I actually have heard already some queen producers, they're having issues with their queens being able to mate appropriately, because again, it's cold, it's rainy, they can't go out and mate. Of course, they don't go out when it's raining. They actually don't go out when it's cloudy. They need very specific conditions. They're very finicky. But once you have these issues, right, such as poor weather conditions or lack of healthy and mature drones, right? So if they're out of sync, the drones take 24 days to develop, queens take 16 days to develop. So if the queens emerge before there's any drones that are mature and available, she won't be able to mate properly, right? Or healthy drones. If you have issues with mating, you can have these suboptimally mated queens. And I'll just walk you through these 3 pictures. This is from Tom Glenn from his website. So this here is a spermatheca. The spermatheca is where the queen houses the sperm from her matings, right? And this spermatheca here is clear, which means that this is a virgin queen. This spermatheca here, and this is actually where the tracheal net is removed, so you can see clearly inside. This spermatheca is of a fully well-mated queen. You can see the difference. Obviously, this is clear, this is very creamy. And if you had a better camera, you could see some marbling inside the spermatheca as well. And now this is where we start having issues. This queen has mated, but you can see that she most likely has not mated sufficiently and properly. Right? So she might have gone out on a mating flight, mated, came back, and it started raining. And after a little bit, if she can't go out again and finish mating, she will start egg laying. But fairly quickly, she will run out of sperm and start producing drones. And I'll show you some of those photos as well. And of course, when you're thinking about the queen health, in addition to the drone health, right, we have to obviously think about queen health. And poor queen health can be due to a number of things, like poor nutrition, pesticide and even miticide exposure, right? Diseases, rearing conditions could be poor overall, right? So a number of different things that could be taken into account. And I'm telling you all of this, not because I know that not all of you are going to run out and start rearing queens, but these are the things to think about when you're obtaining queens also, right? From your queen producers, and just think about things that they have to have in place and deal with to produce a good quality, well-mated queen. So again, if the queen doesn't have enough healthy drones to mate, or there's something wrong with the queen herself and she wasn't able to properly mate, this can then lead to a number of issues with the queen, poor queen pheromone production, which can lead to queen replacement, right? And you might say, well, okay, queen, if you don't care about necessarily, let's say, honey production, right? You might want to just let the queen or the colony replace the queen and her mate with whatever is in the area. One thing, of course, to think about is if you, of course, you're in Humboldt, so you don't have to necessarily think about this, but if you are in areas where you have undesirable stocks, such as, for example, Scutellaria hybrids, you might not want to let your queen mate with whatever is in the area, right? Because you might end up with Africanized honeybees, and they can be highly defensive, right? So these are the things to think about. But again, honey production is also pretty heavily reduced if you have a break in brood cycle. I think somebody told me if you have a loss, if you're splitting, for example, if you have a loss of 1 frame of brood, that equates to loss of 2 frames of honey. And I think it was one of the folks who was with the American honey producers. So You don't really necessarily want to have the colony supersede the queen and replace her herself, because it takes a long time for that replacement to take place, right? Again, this can lead to reduced amounts of sperm stored, so she runs out of sperm to fertilize the eggs. And it can lead to reduced genetic diversity in the colony, which then could lead to issues with colony health and productivity. One of those issues is inbreeding, right? So if you have a queen that is poorly mated or doesn't have a diverse amount and diverse stock, I guess, if you will, of drones, a good diverse supply of drones in the area, that could end up leading to inbreeding. And this is because honeybees have this single gene that determines their sex. There are lots of these different versions of this gene, or a copy of one copy of a gene is an allele. It's called an allele. So there are lots of different versions of these alleles. I think the last time I talked to somebody who worked on this, they said there are probably about 21, they said 20 to 25 different alleles present in areas in California. I think they were working in Northern California, so around here, right, at that time. And these alleles can be lost, can be added. Of course, mutations happen, right? So these different versions of this genes, right, are present in the environment, and then we get one version of the gene from the mom, one version of the gene from the dad, right? So if you are a haploid bee, which comes from an unfertilized egg, right? So it means you have only one version of that allele, of that gene, you become a male, you're a drone. If you are a female, right? If you are becoming a female, most likely you have gotten two different versions of this gene, two different alleles of this from this gene, one from mom, one from dad, and then you become a female. You can become a worker or a queen. Where the trouble begins is when the queen and the drone contribute the same version of that gene, the same allele to the offspring, right? So you have the same allele, and what happens then is the diploid males are produced and the workers remove them. And then you end up having issues with what we call shot brood, right? So that could be a problem. And essentially what it is, the brood pattern is very spotty. And I have lots of nice photos of different types of brood pattern that you can be looking out for and looking at as you're going through your colonies, right? So shot brood pattern is essentially when you have brood pattern that has a lot of empty cells within it, right? So that's on inbreeding. Things to pay attention to, again, I already mentioned brood pattern, right? So you want to pay attention to the brood pattern because that can tell you quite a bit about potential status of the queen, right? Status of the queen. So you want to be looking at the brood pattern. We already discussed shot brood. So you can see these cells, for example, a few cells that are empty here and there, that's fine. But you don't want to have a lot of those empty cells within the brood area, right? You want to be looking for signs of any disease potentially. In particular, we're talking about chalk brood or other diseases as well, especially brood diseases, but queen injury or worker behavior. So when you're going through your colony, in addition to looking at the brood pattern and any signs of the disease, you want to be looking at the queen. If you can find her, right, and you should be trying to find the queen if you can, every so often at least, maybe not every time, but pay attention to what she looks like. If she looks like she's been chewed on, if she's missing feet, right? The tarsal pads produce pheromone as well. So if she's missing tarsal pads or tarsus, if she's missing tarsus, the fingers, if you will, of the queen, like the bottom parts of the legs, which I've seen in the colonies before, you might want to think about replacing the queen because most likely the workers will replace her before you do it, right? So these are some of the things to be paying attention to and looking out for when you're going through your colonies. And again, worker behavior, if they're not gentle with her, if they're chasing her and try to bite her and try to get rid of her and try to maybe ball her up, of course, looks like they're not accepting of that queen anymore, and they might want to replace her. So those are all the little things to pay attention to. Brood pattern, right? We talk about brood pattern a lot. And the brood pattern is essentially capped. What we like to look at is this capped brood area, which is a little oval within the central area of the frame, right? So usually it's the brood pattern, then you have some pollen around, and then you have nectar or honey that's on the edges of the frame. And this is from Lauren's study, and she does this all the time. She evaluates these brood patterns of these different stocks and different colonies. So she has evaluated this brood pattern to be 4.5. Right? So that means it's a really good, solid brood pattern. This is from Rob Snyder photos from one of the publications by Katie Lee. And they also use the score of 1 to 5. Really good brood pattern would be a really solid brood pattern without a lot of holes, right, in it. Empty cells would be a 4.5, 5. It's a little bit subjective, right? So it's really important for the same person to look at the brood pattern over and over again when you're evaluating something. I think they scored this one as a 3, and this one was a 1. And I think visually it's clear that there are big differences between these brood patterns, right? Another thing that can happen, of course, if the queen is suboptimally mated and she hasn't mated with enough drones, or something happened and the sperm died, maybe she was exposed to really high temperatures or even really low temperatures, so the spermatozoa within the spermatheca dies, the queen will start producing drone brood only, and there's no worker brood. Right. So after a while, it kind of flips and it goes from nice pattern or maybe a weaker pattern, and she slowly starts producing only drone brood. And hopefully all of you here, and or at least most of you here, know what drone brood looks like. It's very different from worker brood, right? It has this pattern that looks like they're little bullets. So it's raised caps. It's slightly taller than the worker brood, right? It's not nice and flat, close to the surface, right? So it is raised, it is bigger, and again, it has these raised cappings, wax capping. So that's your drone brood. In fact, there are a lot of drones on this frame. So when you see this, that could signal an issue, right? And especially, so one of the questions that keeps coming up with this is it laying workers or is it the poor queen? Either way, if there are a lot of laying workers or enough laying workers in the colony that produce this many drones, I mean, the queen is not doing well, right? So we'll talk a little bit about this, or a little bit about egg-laying workers and how to requeen with egg-laying workers, if that's even possible. Okay, drone layer needs to be replaced. Diseases, unless you're really fond of just producing drones, which are not going to last that long because then they're going to run out of workers to take care of them. Diseases, you also want to pay attention to presence of any diseases, which could indicate that not necessarily the queen, but the offspring that she's producing might be more susceptible to diseases, right? In which case you would want to potentially requeen the colony with stock that you know might be from a hygienic breeder queen, right? So this is particularly true with chalk brood, and chalk brood is a fungal disease. For those of you who might not be familiar with it, you can see here some of these larvae starting to become mummified, right? The fungi are growing and taking over the larval remains essentially, and it looks just pure white. And it looks like a pure white liquid almost in here. It's not liquidy, right? The actual mummy is not liquidy, but that's what it appears to look like when you look inside the hive. Those are early stages of chalk brood disease. And here we have slightly later stage of the mummy, right? And these are the spores that then, if they're transferred, can cause chalk brood in other cells as well. And one of the treatment for chalk brood is really tricky. You want to keep your hives ventilated, right? In some cases, it could some of the heat could be used as well. So we say that bees being able to thermoregulate is really important, right? Because you can keep these spores under control if you have a nice, healthy, strong hive, and it's said to be a stress disease, can clear up with, we say, nectar flow often. It is also recommended to requeen, right? So you might need to, when you're requeening a hive that's diseased, you might want to remove some of these frames that are diseased, put them in the freezer, right? So clean them up before you put them back, and then maybe put some of the frames, stronger frames with maybe emerging brood, or even open, young, new, fresh, open brood from your stronger colonies, right? And then install new queen. And the hopes are not necessarily that the queen is the one that's going to do anything about the disease, but whatever offspring she produces is less susceptible to disease, maybe a little bit more hygienic, and better able to withstand whatever the impact of the disease is. Okay. Poor brood pattern due to inbreeding, drone layers, right, and disease colonies all could indicate issues with genetic material, essentially, that the queen is able to produce within the colony. This was an interesting study, and actually a really great question that this group of researchers has asked, right? We depend on this brood pattern so much, and we evaluate it so often, and we then decide whether the queen quality is good based off of this brood pattern. Well, as it turns out, what Katie and a few other researchers, including Marla Spivak, have done for this particular study, they evaluated poor pattern colonies and good pattern colonies, right? And they then switched the queens, right? So they did this reciprocal cross foster, basically, study where they took the queens from the poor brood that were producing poor brood pattern, took the queens from the good brood pattern colonies, and placed them in the opposite. So good went into bad and bad went into good. And then they watched what happened. I think they did it for 21 days. They also did some other evaluations of the queens. And what they found was that if you took a poor brood pattern queen and you placed her into a good brood pattern colony, at least for the first 21 days, their brood pattern actually improved, which indicates that it's not the queen, right? It's not the queen quality, but it could be something within the colony itself that is triggering the poor brood pattern in a colony. So it's not as simple, unfortunately, it's not as simple as looking at the poor brood pattern and saying, okay, I'll replace the queen. Maybe give her another chance if for whatever reason you can't obtain another queen, or you want to give her a chance. So one of the suggestions was, not necessarily from this paper, but somebody else suggested that maybe you can take that poor pattern queen and place her into a different colony, right? And give her a frame, a fresh frame, and see if she lays really well over the next 24, 48 hours, right? So if she kind of fills that frame up within the 48 hours or so, she's probably an okay queen and just needs a better colony and better environment. So they go into sperm numbers and sperm viability as well that they've associated with the queens coming from this poor brood pattern. And apparently there was no difference between the good brood pattern colony queens and the poor brood pattern colony queens in sperm numbers in the spermatheca and sperm viability. So again, all of this indicates that most likely it is the environment of the colony that's leading to these poor brood patterns, not necessarily just the queen quality. And one thing that they do say is that they didn't track the colonies long enough to see if the new offspring of that poor brood pattern queen is what was causing the poor brood pattern, right? So there's a lot more to be explored. And I just wanted to put this little photo in here. This is another way of evaluating the brood pattern. This is a square that is 10 by 10 cells, right? So it has like 100 cells within it. And then you know that there should be 100 full cells. And then you count out the empty cells in there. And you simply subtract number of empty cells from 100. And in this particular paper, and I think that's pretty common, anything that has less than 80 full cells or brood cells, right, within that square, or 80% of the cells, it's considered to be poor brood pattern. So 80 or below. And again, I think this is open access, so you can take a look at that specific paper. Okay, so that was a little bit about what to look out for in the colonies, right? When you're going through it, and making a decision whether you want to requeen, replace that queen or not, and you don't want to just simply replace the queen because she's been in your colony for a year, right? You want to keep an eye on her and see if she's producing well or not. And again, just keep in mind that poor brood pattern might not always not indicate the queen quality. So unfortunately, it's not as simple and straightforward most of the time with bees as we would like it to be, right? So, okay. So if you do decide to requeen, right, you would need to decide, again, what would you like to requeen with? And there are some options for you. Most commonly, what happens is beekeepers will introduce queen cells that are ready to emerge, right? So ripe queen cells, they're right here, or mated queens. Usually a beekeeper will not introduce a virgin queen, right? The reason for introducing queen cells is because they cost less. They might be easier to obtain from like a friend beekeeper or from your club. Then whoever is giving those queen cells to you, right, they don't have to worry about mating the queen, evaluating her, and then shipping and selling her. So you could decide to go with queen cells. I think the last time I checked, they were going for about $6 to $8 per cell, right? And of course, you can also purchase a mated, fully mated, ready to lay queen. This is really important. And I put it up front because these are some of the things that have thwarted our attempts to requeen a colony in the past, regardless of whether we were trying to requeen with a cell or requeen with a queen. No matter what you're introducing, you need to make sure that your colony is as accepting of that potential new queen. And you can assure, or at least make the best possible environment, right, for that new queen by destroying all of the queen cells prior to installing your new queen, right? So you want to go through the colony that you want to requeen, and you want to make sure that there are no queen cells. There's no queen, right? But there's no queen cells, and make sure there are no newly emerged virgin queens in the colony. We've had that happen before. We thought there was nothing in the colony. We added a new queen and came back like, why is she not in there, right? And as it turns out, there was a virgin queen that was out on a mating flight and we missed her, right? So we were checking the colony in the afternoon, which is when they go out to mate, we missed the queen that was out on the mating flight. She came back and the workers killed the queen that we were trying to install. So do the preparations and this queen installation in the morning. Okay, so if we're going with the queen cells, right? Let's say you decide you found somebody who sells queen cells and you're buying them, or somebody has queen cells and you're ready to accept those, right? You have a queenless colony by accident and you're desperate, you really need to install a cell, or they might not be, you might not be sure that they have enough brood to make their own queen cell, right? Make their own new queen. You can go and purchase these cells, and in fact, nobody ships cells. You'll have to go and meet the person who's selling you queen cells, and then you need to transport those back to your own apiary. You'll need a container that will fit. Usually what we tell everybody and what's easiest and what we've done in the past is just a plastic water bottle, or a water bottle that can have about 35 degrees Celsius water in there, or really hot water in there, so you can keep the environment warm inside that container. And it should be about 35 degrees, right? The environment. You don't want to put the cells obviously directly on that water bottle. You want to put some towel on the water bottle, and you can also have a number of different ways that you can house those cells. The best way is, of course, if you still have the cells standing up, right? The way they're supposed to be in the hive. So we have, these are cell protectors right here. They look almost like the hair curlers. So they're cell protectors. You can put the cell on top and you can transport them that way. We have had folks come and transport the queen cells in egg cartons. So this is a queen cup. Right, the nipple here you can see is from the queen cup. You can also do this. You can just gently lay down the cells and make sure, if you're not going very far, you can transport them like this. Just don't put them directly on this hot water bottle, hot water, whatever you decide to have that will create that temperature increase in the container. Make sure you don't put the queen cell directly on it. And of course, you can transfer them in battery boxes, wood chips, shavings, queenless nuke also will work. So a number of options for you. So you got your queen cells, right? You say you wanted to requeen with the queen cell. What do you do now? You want to place your queen cells into your colony in the brood area. So we usually go in the middle of where the brood area is, and we will push in these queen cells into the wax, right? And obviously always pointing down, what they normally do. And we put it back into a colony and cross our fingers, essentially. What we normally do is we will, again, push it into the frame. You could protect it with a cell protector if you want to make sure that maybe they won't destroy the cell before the queen even has a chance to emerge, right? We most commonly introduce one queen cell per nuke or per colony. You can try two, they will kind of choose which one they want, but most commonly, just if you're buying cells, you will introduce one cell per colony. You can use obviously you need to use the queenless colonies with some brood, right? And especially with the brood that's older and is about to emerge and will take care of that queen cell if it's a younger queen cell for some reason, right? And also those emerging adults will eventually start to take care of the queen as well. You want to make sure that there's food in there as well for when the queen emerges, so the workers can take care of her. And then eventually she will go out and mate, right? So you want to make sure that there's always space for queen to lay when she is ready to lay. And I see, so I forgot to mention, I know this is being recorded, but I'm also happy to share this PowerPoint with everybody. Maybe I'll send it to the club and you can share it if you wanted to, so you don't have to frantically write everything down. Okay, so the cells are usually ready to emerge within the first 24 hours. Usually whoever is selling you cells will ensure that they're ripe, mature, ready to emerge cells, right? So you need to work quickly and efficiently. If you bring them back, you should probably install them the first day when you bring those cells back. And then after you install them, you should come back and check the colony for the queen emergence, usually within the first 2 to 3 days, maybe a little bit later. Again, check in the morning, right? And you will be able to see if that cell is emerged or if the workers have chewed her out. Hopefully they didn't. You saw that video of the queen emerging. There's the little flap, the little cap that the queen will cut out and open the cell, and that usually indicates that the queen is emerged. If you see any chew holes on the side or chew marks on the side, usually indicates that they got rid of the queen cell, right? So that's not, you don't want to see that. If that happens, then you need to get a new queen cell or a new queen, right? If she's out, just if you can find her, right, just observe her for a little bit and see how they're behaving towards her. Again, there will likely be no retinue, so not a lot of workers around her. But you also want to make sure that they're not aggressive towards her, so they're not trying to chase her, bite her, chew her, right, or sting her. And if the queen seems fine, right, come back within the next 10 days or so to check for mating, signs of successful mating, right? Because she would, at that time, hopefully if the weather is appropriate, would have mated and started egg laying most likely. And you don't want to disturb the colony that's trying to accept a new queen too much. So you don't want to get in there every day to check, right? Just be mindful of that. And after she comes back mated and you see there are eggs present, mark the queen, right? Mark her so you know that that is the queen that you have placed in there. It's really a good habit to get into, to mark the queens. And the question again always comes up, should we mark virgin queens or mated queens? I've always commonly marked virgin queens just because it was easier for me to pick them out when they were coming back from mating flights. But some say that the birds see them easier, so they will pick them off. I don't know anything about bird vision, so I'm not gonna make any claims, but oftentimes people will wait to mark the mated queen. It's just easier to deal with her too, because she's not as flighty. All right, and I actually have a quick video, which I'm sure is not gonna work on there again. I have a quick video of how to mark a queen. So if you've never done it before, might be intimidating to you, but there are tools that can help you. Like I think they call it a queen muff. So you put the queen into a little container. It has a mesh on top and you kind of push her up gently, of course, and you can mark her through the mesh. But if you're brave, right, and if you don't have that and you don't want to mess around with the different things, right, like that, you can just essentially gently hold the queen down and just mark her on the thorax, right? So you want to mark her on the thorax, right behind the head. You want to make sure that she's not marked on the head or on the antenna or antennae, because she can't really smell, right? She can't use it for its intended purpose. So just pin her down gently. Don't grab her by the abdomen if you can. Avoid that. Grab her by the thorax and then just mark her. And then there is, if you didn't know this, there's a sort of an, I guess, an international queen marking system or color code system. So you can mark your queen with a color based on the year that she was born in, and that year or the last digit of the year that she was born in is associated with a specific color. So this year we're in 2023, so the queens should be marked red, right? And because we no longer have queens that live 5 years, right, or more, this is the reason why we reused the color, right? So you have years that end with 1 or 6 are white, years that end 4 or 9 are green. So the queen that you find in 2009 that's green is likely not the queen from 2004. Most likely it's the queen from 2009, right? And these are just acrylic paints that you can purchase. You can buy them from like Man Lake, even in Walmart, I think. Okay, so now you have your queen that you've mated and took care of it. And let's say she's egg laying, you're good with that, right? So that was from your queen cell. However, again, most commonly, what you're going to end up doing is getting a mated queen, purchasing her, or getting it from somebody in your club. So the mated queen, if you are buying her, will be shipped to you most likely in this California cage, right? It's just a pine cage that has mesh on it, and then it has some candy at this end, right, at one of the ends, and a little plug. And it usually is shipped with attendants. The queen is shipped with the attendants, right, inside the cage. She also might be shipped in these battery boxes with additional loose attendants. I'm still loose. So I've made the mistake before of opening the battery box inside, and all of those attendants would just fly away, right? So just make sure if you're doing this to open up the box outside and let all of those attendant workers fly out. If you cannot put the queens in your colonies immediately, right, you can place them at room temperature. We sometimes have to wait to get to the field or get to the specific AP. So make sure you put the queen cages with the queens in a room, in the space with at room temperature, right? So your kitchen, whatever, and provide some water. So they already have this candy at the end, right? That's plugging up the cage. So just provide some water, and you can just do that with a little cotton ball and just set it on top, and just make sure that it doesn't hit the queen, right? So you don't want to cover the entire mesh cage with the cotton ball. You just want to put it on one side, preferably further away from that candy, sugar candy. And you want to allow the queen to be able to escape from water. You don't want to flood her, right? Okay, so this is again assuming that you are trying to requeen a colony, and it's not necessarily an already queenless colony, right? So we're starting from scratch. You determined she has poor brood pattern. You don't want to wait around anymore. You want to make sure that you're getting a new queen into the colony as soon as possible. So you want to go sort of through this process, or at least this is what we have done fairly regularly, and we probably have 95% success with queen acceptance, which is pretty high actually. We haven't, I don't know what we were doing, but when we were doing a lot of requeening, usually we have pretty good success, and this is the way we do requeening. And you can slightly alter it, of course, but I'm going to go just step by step through these. So of course, the first obvious thing to do is to make your hive queenless. And sometimes you also want to, instead of just removing and replacing the queen, you might want to make a split. You might want to split your colony, so you now have two, right? Or again, you simply find a queenless hive, and then from here on out, the process is pretty much similar. If you are making a split or you're removing the queen, you want to make sure that you do that at least 48 hours. I would say 48 hours. Some people only do 24 hours. Others say do it 5 days before. We usually do it 2 days before we will install a new queen. Right? So we remove the old queen, and then the next day or after 2 days, we will go into the colony and make sure that we destroy any queen cells. This is, again, really important because they will still preferentially want to rear their own cells, rear their own queen. Right? So the queen cells can be anywhere on the frame, right? So these are your swarm cells. And usually the emergency cells are on the face of the frame. So remove any queen cells that you find. Again, your queen might come in these California cages or this plastic cage. And interestingly, this plastic cage or these plastic cages are actually impregnated with the queen pheromone. So if you take this cage and you don't have anything in it, no queen, nothing, just a fresh new cage, and you go into an apiary and you sit it down on top of the colony, pretty quickly, all of the bees, you'll see bees will go nuts over it. The workers will cover the cage, they will lick it, they will try to explore it, they antenate it, they're acting as if it was a queen. So these are already kind of helpful to you if you are trying to increase the success of your requeening. But that would mean you would have to move them from this cage into this cage, which is what we do, but you don't have to do that. Okay, so you have your cage with the queen inside, right? And you need a cap. If you have this California cage, it comes with a candy cap already, right? Usually a cork or some wax or masking tape or something, right? What we do, if you have the candy, you take a nail or some sort of a stick and you puncture that candy through with the nail. Make sure you don't spear the queen on the other side, right? So it's essentially just kind of giving them a little bit extra help for those workers to cut or eat through that candy to get the queen out as soon as possible, because you also want her to start egg laying quickly. If you don't do that and you don't have, for some reason, the candy at the exit or the hole, you can put, we often will put a little bit of grass in there, right? And the workers will remove it fairly easily, or some tissue paper. They will remove it also. So either one of those works. The queen now, or the cage now, needs to be placed inside the colony, and it is placed between two frames in the middle of the brood chamber, between those two frames of capped or emerging brood, right? Usually the emerging brood, again, you're kind of just trying to promote new workers potentially emerging and getting used to the queen, taking care of her, right? What we do quite often, and actually I think we do this pretty much all the time, we spray the workers that are around the cage as well as the cage a little bit with sugar water. So we just have a sprayer with some 1-to-1 ratio of sugar to water, right? So sugar water solution, and we spray it a little bit, spray the workers, and then they start licking each other, licking the queen. It's almost, we're promoting the positive interactions, and they're picking up that pheromone and they're spreading it throughout the colony, right? If they're cleaning out, trying to clean out the queen, if she doesn't hide in there. When you're placing the cages, the candy hole, or this hole with the plug in it, faces usually sideways, right, to the side. We usually do not put it this side up, because if it's hot, for example, that candy, if you have candy in there, it can start dripping and melting, and it can cover your queen with sugar completely, right? It's just, it can actually get her stuck in there, and I've seen that happen too. So you can face it down. This is probably the most common configuration. With the queen cages that are the California cages, right? The mesh, I usually put that down. So I may face the mesh down, right? In a couple of days, come back, check on the queen. Again, if you see any queen cells and she's not out yet, just remove those queen cells, or even if she's out, just remove the queen cells. If the queen is not released already, right, from the cage, and they haven't chewed her out, you could at this time possibly release her inside the hive, but monitor to see if, again, the workers are being nice to her, right, licking her, antenating her, taking care of her, or if there are workers that are being really aggressive towards her and they're biting, stinging, chewing, chasing her. If that's the case, you don't want to leave her out. You want to bring her back, put her into the cage again, and then try reinstalling them. Right, and then come back and check again on the queen. If they're being nice to her, right, leave her. Then she'll start egg laying and everybody will be happy. And then come back again. It's like day 7 or 10. Just come back and see if the queen started egg laying. And hopefully you all know what eggs look like, right? And hopefully all of you have been able to and have had an opportunity to identify eggs inside your colonies. It's a little bit difficult to see them. They look like tiny little grains of rice, right? And they're attached essentially to the bottom of the cell in the middle. So there's the eggs, and you might even see some really young larvae. If they're not accepting her for whatever reason, you try this again, you try it again, you try it a few times, she's still alive, but they're not accepting her, you might want to at that point consider using a different queen. Right. So I think these are just some tips for troubleshooting installation. I think we already talked about this. Try a few times, but of course, give up and replace her with another queen if you don't see acceptance after a few tries. Remove queen cells, make sure there's not the old queen or the virgin queen running around, right? Check for worker laid eggs. It could be that they're not accepting her because they've already started laying eggs. And usually we will see egg laying workers start doing this within a couple of weeks after the queen loss. This is also why it's important to check your colonies fairly regularly so you can take management measures that you need to promote the colony and make sure that the colony is actually a colony and has a queen. Okay, so speaking of egg laying workers, right? We already mentioned egg laying workers when we were talking about the brood and brood laying, possible brood laying queen, right? Another potential is that the workers started egg laying themselves because the queen has been lost for usually about 2 weeks. So the workers, when there's no queen, will activate their ovaries or can activate their ovaries, and they will start laying eggs. And you can tell the difference between eggs that were laid by a queen versus those that were laid by workers. So these here are egg laying worker eggs. And you can tell that they're not very good at it. They will often lay multiple eggs per cell. And actually, these eggs will quite often be on the side of the cell because their abdomens are shorter, so they can't reach all the way down into the bottom of the cell. And they will lay those eggs on the side of the cell, on the walls of the cell. Whereas the queen lays 1 egg per cell. Every so often, you will find a couple of larvae, young larvae, and I don't know what the glitch is, right? But every so often, you'll find a couple of larvae per cell. And usually that is when the queen is really young and just started egg laying, so she's still learning, right? But these are your egg laying workers. And oftentimes, it is really difficult to requeen an egg laying worker colony. Doesn't mean that it's not totally impossible, but you have to decide whether it's worth it to you to waste your time and potentially waste your resources to try and requeen that egg laying worker colony. So because it's so difficult to requeen an egg laying worker colony, you might want to consider preventing the colony from becoming colony with egg laying workers. And that can be done by providing synthetic queen pheromone. So you can prevent it by providing this, I think, temp queen. You can purchase this from a beekeeping supply store. I think Manlake has it. And I think actually, in fact, I have some in the freezer right now with me. And they're just little tubes that have been impregnated with this queen pheromone. And you can use this little tube and use a zip tie to attach this pheromone to the frame. And it is dispersed throughout the colony. Workers will come to it, lick it, touch it, intonate, whatever, and they will disperse it throughout the colony as well. And they will think that there is a queen. So they're not going to rush and start activating their ovaries, right? The ovary activation is suppressed with the queen pheromone. If there's no queen pheromone present, the workers will start building queen cells, usually within the first 24 hours. You can see new cells, right? Again, if you don't want the workers to requeen on their own, you don't want these emergency queen cells, then you, again, might want to prevent the workers from becoming laying. And also you want to give a chance for your new queen to come, right? So if you don't have any queens on hand, you need to order, you need to find a queen somewhere. So this will give the colony an opportunity to still think that the queen is there. And because there's most likely still some brood present in the colony, that is another signal for them to think, okay, the queen is still here, right? So that could help, and you can purchase this. And as I said, I have some in the freezer right now. You can hold it, have it on hand if you need to use it. As I mentioned, it's almost impossible to introduce a new queen into a worker laying colony. People have tried, or beekeepers have tried different things to try and improve this success. For example, if you have these egg-laying workers, one of the suggestions is to take out frames of egg-laying worker eggs and put in open brood frames, right, from the queen from another colony, and sort of hope that that will trigger the workers to suppress their ovary activation and maybe start rearing a new queen. So if they start rearing new queen cells, then you can start introducing a new queen on your own, right? That usually means it's pretty safe to introduce a new queen. There were some beekeepers I've talked to that say that they had some success with introducing queen cells instead of a mature queen, mated queen. So that's a potential. You can combine it with the queen right colony, right? Try combining it. In all of those cases, the recommendation is really to remove those frames from the egg-laying worker colony, right? As many of those as you can. Or ultimately, what you can do is just dismantle the colony entirely and take those frames into a freezer, kill the brood, give it back into a strong colony, or start a new colony, and just take those adult bees that are there, shake them off near an entrance of another colony. And hopefully some of them will go into a new colony and be accepted, right? So there are some options, but usually it's kind of a done deal. Another thing to think about as you might be considering requeening hives, and again, I understand that this is not necessarily for you specifically because you are hopefully in the area that doesn't have any squidulata hybrids, but just something to keep in mind is you're maybe talking to your friend beekeepers down in Southern California, right? Requeening hives, or actually I should start here. Keeping hives with squidulata hybrids or Africanized honeybees or overly defensive colonies is actually illegal in the state of California. So you want to make sure that you requeen. Folks who collect swarms down in Southern California often find themselves, if they don't requeen, that they actually can eventually even go into the colony to manage it because the colony just ends up being so defensive. So the first step, if you do end up with a swarm, is to requeen that colony that might be Africanized. They're fairly persistent, right? And they'll keep and try and keep their genetics in the hive as long as they can. So they will, if it's an Africanized colony, then they will continuously try and rear a new queen if they have brood from their own mother, right? So if you are trying to do this, the best thing is to make smaller colonies, right? So if you already have a colony that's going, you might want to consider splitting it. If you have a swarm, it's already hopefully fairly small amount of bees, so that should be okay. But reduce the colony size by splitting. It seems like smaller colonies do accept queens a little bit more readily. Instead of keeping the queen in the cage for those 48 hours, leave it in for a week, for an entire week. And in fact, I would recommend you do not take that little cork off and do not pierce the candy, just leave her in there so that she can get out, right? So she's protected and they're hopefully going to have a harder chance of stinging her and killing her, and they will get used to her pheromone, right? So leave her in for a week. And then stay on top of that queen cell removal, right? They're going to try and continuously requeen if they can. And again, you can use added protection, use some duct tape and put it on that hole so you can even further prevent the workers from chewing through, getting to the queen and killing her. Right, so it's a process with this, but again, hopefully you don't necessarily have to think about it and worry about it, but now you know, just in case. Another thing that I would highly recommend is for you to keep track of your colony status, including requeening, and that also includes the characteristics of your queen, or if you specifically purchase, let's say, I don't know, Saskatraz queen, right? You want to make sure that you keep records of it, and then you can also track to see how that queen is performing, and if you need to take any other action later on as she progresses through the season. There are a number of apps that you can purchase now. I don't know, honestly, how much they cost. None of them are that expensive, right? And a lot of them, most of them, what they have available very different things on them, right? But what they have available is a platform for you to be able to easily enter the data for specific colony within a specific apiary. Some of them have a QR code that's associated with the colony that apparently you don't even have to have a QR code scanner to scan. It just picks up, I don't know if it's a chipped QR code or a chip or something that you essentially your phone will pick up on the colony as you walk by it. So it's already on your phone when you pick it up. It's already on your phone and you just enter the data that you just tracked, and you have an idea of what that colony is doing or has been doing the prior inspection. Or you can just go simple and use note cards and Excel. That works for us. We've tested a number of these different apps, and they all at that time needed some improvements. I'm sure they have been improved quite a bit by now, but Excel and note cards, especially if you only have a couple of hives, work just fine. And I think I'm going to stop there. I've already talked a lot, I know. I started off by keeping things really short, and now it's a topic I really like talking about. So hopefully you've received some useful information here. And if you have any other questions as a follow-up, I thought I had my email address on here, but it's elnino@ucdavis.edu. So you can, I'll put it in the chat, so you can always contact me and ask if you have, as I said, any other follow-up questions to this. So thank you. And I see there are some questions in the chat. I'm going to throw in my email in here, and then I'm going to take a look. So the first question by Donna is, cage is pressed into wax between the two frames or somehow suspended. You can push it in between, yes, right under the lip of the frame. We usually will put it into the wax, especially if it's the wood cage, right? Because the sides of that wood cage are wooden. So if you push it between underneath that lip of a frame, it's not going to damage the queen. With the plastic cage, because it's completely meshed, right? It's open. You don't want to put it between the wax, and you don't want to press it between the wax, because then they might not be able to get to the queen. What we do then is we actually pinch the cage between the top of the frame, the wooden part, that lip of the top of the frame, right? You want to pinch the cage between, and then just make sure that it's being squeezed between those, and that workers can still access the queen and feed or take care of her smeller, right? I thought workers didn't start laying until most of the pupae have emerged. When you start thinking about it, that's about the timeline, right? If you have it, it's like 2 weeks or so. There are always, I know it's 3 weeks, but about 2 weeks, right? There are always some laying workers in the colony, very, very low numbers. I think Andrew Barron found it's like 0.1% of the drones in a colony come from workers. I have definitely seen colonies start workers egg laying within a couple of weeks, even with the pupae present, right? Once that open brood is capped over, that reduces that brood signal for them, and I've definitely seen them start laying eggs within a couple of weeks. A lot of the ovary suppression is actually done by the queen pheromone, a lot more than the brood pheromone, right? So queen pheromone is really important for this ovary suppression. We have a difference of opinion about the term queen cup. Isn't it a queen cup if it has nothing or an egg, or should it be called a queen cell if it has an egg? I call it a queen cell if it has an egg also. These are all, so people, argue over these things, but I don't know that I have the authority to make that decision, right? But I usually call it a queen cell, even if there's a possibility of them to start producing a queen, right? Because the queen cups, they will continuously keep making those. They will draw these out, they'll tear them down without ever placing an egg in there. So I use the terminology where I say queen cup if there's nothing in it, queen cell if there's a possibility of a queen. Requeening, we typically place the queen cage on top of the frames using a spacer or a feeder box to make room for it, rather than placing in between frames. Any comments on that? We've done that in the past and it works fine. I do feel like the workers are prompted a little bit more to approach the queen and take care of the queen and have a greater chance of encountering the queen if she's there in that brood area, right? So we like to put it between the frames. Okay, email. Thank you. How often do you recommend removing queen cells while introducing a caged new queen daily? No, you don't have to. I think if you introduce, right before you introduce the queen, make sure you remove those queen cells. And then when you come back to check to see if they released or if they're, just do another scan and see if they have managed to build any other queen cells, because they will try and build queen cells from really young larvae. So there is that like 2-3 day period. Once you're past that, they usually stop trying to rear queens, right? So you have that maybe like a 5-day period. So right before you install her and maybe a couple or 3 days later. How often? Okay, any tips for finding queens, virgin queens prior to splitting and or requeening? I don't. Oh, like finding them in the colony. I thought you meant finding them for purchase. Finding the virgin queens prior to splitting and or requeening. I don't. Really good eyesight and patience. We do take the frames one by one, and if we're trying to look for the queen specifically, we will pull a frame out of a box and then put her in. If we don't find her, right, and we're sure that she's not there, we'll put that frame into another empty box next to the colony. So that way we know that we've checked that frame and chances are very, very low that she's on there. So then we go through those frames and just move them into another box. Right, that is to me works fairly well. Also make sure that oftentimes the queen is not always on the frames. She can be on the bottom as well, right? So just check everywhere in the colony. And I've seen some people, and people do some crazy things, right? They try to ensure, and these are, when I say people, I mean researchers. I've seen people essentially shake the bees out and then go through the bees shaken into a container and make sure that they find the queen that way. To me, that would be harder. I don't know if there's any way you could shake the queens out because they're small. You can use like a queen excluder or something. Workers will fall through and the queen will stay on top. That's crazy. I would just go frame by frame, move them into another box. And that will probably give you the best chances of finding her. And then temporarily installing queen excluders between brood boxes. Yes, you can do that too. You can absolutely do that if you have a mated queen, right? If you have a virgin, they're not going to be laying eggs or shouldn't be laying eggs. But if you have a mated queen, you can put the excluders between the boxes and come back and see where the eggs are. Tips for finding queens, colony size. If a colony is 4 full medium boxes, 4 full medium, I'm not sure, 4 times full medium boxes is or like 4 boxes, 4 medium boxes. I'm not following this. Too large to have a good probability of successful requeening. We usually requeen when the requeen, yeah, install a new queen when the boxes are 1 to 2, right? Just one or 2 deeps. So I think that's probably about 4 medium boxes or so. They seem to do okay. And this is, I think, a little bit more crucial when you're installing European queen, for example, into an Africanized colony. Another thing to keep in mind is that often what we have seen in what researchers have noticed is that queens of different stocks and different genetic background, and I'm talking about subspecies, right? Different subspecies might not accept the queen as readily. So if you have an Italian colony and you're trying to install, I don't know, or a Carniolan queen into that colony, they're not as readily accepting of that queen as they are if you were to try installing an Italian queen. So something to keep in mind. And again, it's nothing to be afraid of, right? It's just might take you a little bit longer to get that queen accepted. Do you think brood may have more empty cells in capped brood area during the winter for heater bees than in warmer season? More empties. Janine, I'm not quite sure. Can you explain that a little bit to me?
Well, I'm just thinking that it seems to me when I've checked brood during the, like January or February, it seems to have a few more holes in it than it does during like May. And
So
I'm
early-
wondering if that's because they need more holes for the heater bees to keep the cat brood warm.
I don't know. I would think that that's because they're just starting up again to produce brood, right? And it might take them a little bit to get going in terms of queens to get going. I don't know about that. I've been wrong before. I don't know, but it could be that it's just taking the queen a little bit to get going, right? And it's a little bit slower producing eggs. But anybody else? I think I heard somebody wanted to say something, so maybe, yep.
Mangum, who writes for the Bee Journal and shows infrared pictures, his pictures show the heater bees inserted into empty holes in the cell.
Mhm.
So, and his opinion was that, yeah, there's a reason for those empty holes. It's not, or bees with their tail end sticking out. They're just not hiding out from the work.
Yeah, I don't.
So how much heating is done in inserting yourself into a cell? Is that the way they always do it, or?
No, so that's another good point. Like they don't, when they're heat, the whatever, right? When they're trying to warm up, they are essentially like, what am I trying to do? Their muscles, right? They're contracting their muscles. Thank you. They're contracting their muscles really quickly and fast. So I don't know how much room they would have for movement of that type too. And
that's what all these pictures show them
weird and comfortable. I mean, bees.
Pictures all show them inserted in cells and nice and hot. And they're not moving their wings, so they don't have to do that.
Yeah. So That's interesting, very possible.
I
That's
mean,
all.
just
I'm
because
gonna
he's
say.
got pictures, that's what the pictures show, doesn't mean that
Yeah.
that's where all the heat.
That's what
comes
it is,
from.
but that's an assumption. I
Yeah.
totally get what you're saying. It could very well be, but again, I think, as I said, could be that the queen is just getting started again. And also I'm going to look up that article and find it and see what they say. And I always learn something new too. It's the beauty of working with honeybees. You always learn something new. I asked my kids this morning, I was like, what did you learn in school, or this afternoon, what did you learn in school? Like, nothing. Like, that can't be. Even I still learn something new every day. So you better go back to school and learn something. So I'm definitely going to look that up, Dick. Thank you. And Janine as well, of course.
Yeah, you know who that guy is.
To buy, is it recommended for a first-time beekeeper to buy queens to start their first hive? Is that discouraged because of lack of experience? So you will need to have a queen. I mean, I'm not sure, who's this, Joey? I'm not sure, Joey, how you're starting your first hives, right? But if you're starting your first hives, for example, from a package, the package will come with the queen. So you need to have that queen, right, to start the package. And I don't know if you're here, you can unmute yourself. Feel free to ask a question. But go ahead.
I would be starting from zero. Like, I don't have, like, I put out a couple of bait hives. I built some boxes and put out a couple of bait hives. And, but I don't, like, I am green as redwood trees. Like, I don't know. I know something, but I would say I don't know anything, and I'm starting from zero. And so I'm wondering if buying queens would affect or be discouraged because I don't have any experience, and should I start another way?
So you're in the right place. And I highly recommend, if you haven't done so already, to take some classes with the club, right? And get a little bit more education on that. But when you're starting your colonies, if you are capturing a swarm, for example, that swarm, you want to make sure that the queen is with that swarm. So when you put them into a colony, into a hive, right, into that box, that the queen is already present. If you, and it sounds like that's what you're doing, you put some bait hives out. So the swarm hopefully should have a queen. And if you are getting that swarm into a bait hive, right, that should come with a queen. And then if you decide you can't, that's not working, and you're trying to get a package, the package, you can purchase it definitely without a queen, but packages normally are purchased with a queen. So you'll have to get that package into a hive and then put the queen in the hive, right, with the workers, so she can start laying. Maybe another easier way for you, if you're just starting and you kind of not sure before you take some of the classes with the club, right? You might want to consider purchasing a nuke, which comes as basically a half-size hive, right? 5 frames, they come with the queen that's already laying some brood, and then you can think about increasing and moving that as the season goes on, moving into a bigger colony, into a bigger hive, and grow that colony. But you need to start a colony, the queen needs to be there, right? You can't start a colony without a queen.
Yeah, I understand that. I know that. But what I'm saying to you is buying is, if it's your first time, if you're starting with nothing and know nothing, is there a larger likelihood of failure because you don't know anything, starting with like only a queen?
Well, yes.
You can't really start with only a queen.
You can't start without a queen. So that's what I'm saying.
No, you can't start with only a queen. You need
only a queen. Yeah.
You need a queen and a bunch of bees.
Yeah. So Joey, when you're like capturing your swarm, right? That's what you said, bait trap or bait hive. The swarm is going to be a bunch of really young nurse bees and a queen. And there's no way you can start a hive with one or the other. You need workers and you need a queen. Queen will start laying new workers. The workers that are already there are going to be taking care of the queen and the brood. If there's no queen, she won't continue laying. There's nobody to lay eggs, right? So the colony is not going to grow. If there's no workers, the queen on her own cannot start a colony because she doesn't have anybody to take care of the brood and her. So you need both components, right? So if you're starting fresh, I would, and as I said, like I would highly recommend you take some classes and kind of hang out with the club. You, as I said, you're at the right place, right? So get somebody who can kind of walk you through the first steps in the first process, but you need workers, you need a queen. One cannot be without the other if you want to have successful colony.
It's really nice to have a mentor.
Yep.
Yeah. Julia, which part of Humboldt County are you in?
I'm in Bayside. I'll be talking to Hans. I know Hans from prior stuff.
Oh,
So
good.
Perfect.
So I'll be talking to Hans, and I'll use, you know, if he allows me, I'll use what he has, and I'll pick up things along the way.
Yes, absolutely. Make sure, yeah, make sure you have somebody that you're working with who has experience and can walk you through it. Hank, looks like you have a question.
Thank you.
Yeah, this is wonder, when the queen starts being a drone layer, why don't they go into supersedure? It's because she still has pheromones. Usually a colony goes into supersedure when the workers figure out, hey, our queen is failing. Why don't they figure out when she's a drone layer, it's time to requeen?
Get rid of her. I know it's weird. I've seen it all, right? I have seen it all, and I wish I knew what to tell you, but you can have something to do with the fact that they're just not picking up on like any changes in her pheromone, any changes in the different brood presence. I mean, technically to them, evolutionarily, right, they want to propagate any genetic material. So the question might become then, okay, well, the queen is crap, but we have these drones that she's laying, so she's still propagating the genetic material, right, just like they would. So that could be a reason, but I've, again, seen it all the time, and they just keep her around. They take care of her still. She keeps laying drones, and they have her around. Who knows?
If I may, follow-up question. You have a very large hive, a very large colony that is somewhat old with a lot of foragers. You want to requeen.
Mm-hmm.
They usually won't accept her. You might take a while. I have would be a recommendation to break it down into smaller colonies and then requeen each colony.
I would break it down in a couple of smaller colonies, and some they will. So if there's still brood in there, just make sure they have open brood in there, because that can trigger a number of different things, right? The foragers can actually end up reverting back to nurse stage, right? They're very plastic. Their behavior is plastic, and they will regulate that transition, right? And whatever they need, whatever the colony needs are, the workers usually respond to that need. And if one of them being is a lot of foragers, if they now also have open brood, they tend to revert back to that nursing behavior. So that might manipulate the sort of the composition and demographics of the colony a little bit better. But I would try with splitting them up and putting them into a smaller space, like smaller colonies, and then requeen. In no case is the same, right? So just because we think that might work, might not, but you give it your best shot, sort of reason as to what might work best. Usually smaller works better. As I said, promoting those positive interactions with maybe spraying them a little bit with sugar. I know it sounds crazy, and I don't even know how we started doing it and why we started doing it, but we started spraying them with that little bit of sugar water, and it seems to be working really well. No matter what we try to introduce, and no matter into what we try to introduce, that works. And I'm not talking about Africanized colonies, right? But just your run-of-the-mill Italian and Carniolan and Caucasian colonies. So, okay.
I think. Can I ask a question that's off topic?
Yes, and I think, I'm sorry. You know what, there's one more, Mary, minimum, what's the weather we should be looking for to have successful queen mating flights? About 60 degrees, no clouds, no wind. They're so finicky. Hopefully 6 consecutive days seems reasonable, but again, this all has, I wish there wasn't a but there's always a but. I have monitored and tracked queen flights for 3 or 4 years in Pennsylvania, where it was really rainy, and it really varied as to how long it would take different queens to mate successfully. I have had queens that were usually around, 5 to 10 days old. I had queens that would go out, take their orientation flight, be gone for about 30 minutes, come back, never leave the colony again, and be fully mated and be totally fine. And then I've had queens who would go out, take an orientation flight, quickly come back into the colony, hang out in the colony, maybe later in the afternoon go out, take a mating flight, come back, hang out in the colony for a couple of days, and then decide to go back out again. So I had a huge range of what they were doing. So hopefully 6 days sounds like a reasonable amount of time for a queen to go out and mate successfully. And yeah, about 60, 65 degrees.
Wow, because I had heard that virgin queens had to make consecutive day flights, that they couldn't have a break between.
Totally
mating
varied,
flights.
huge variation.
My goodness.
And actually, you know what, now that I'm thinking about it, I should probably dig up my old data, and I've been thinking about that too, because people ask about it, and I should take a look at it and see if I can get any more information from it, but it varies. It really does vary.
Well, I'm glad to hear that, because sometimes we'll have, one nice day or 2 nice days, and then we'll have a break, and
Sometimes,
then
sometimes they'll be fine.
okay.
If we had to wait for 65 every day, nobody'd get mated around here.
Yeah, that's correct.
They do, yeah, they do tend to like, and again, I've seen this, like around 60 at least, and then, oh my God, they hated clouds. They just did not like cloudy at all.
Yeah, 60 we can do from time to time.
Right.
I know. It's gonna be 70 here, or no, it was 70. What was it? It was, I feel like it was 70 a couple of days ago here, so I was pretty happy in
So what do you
Davis.
think about queen mating weather coming up in the Central Valley where our queens are coming from this year? How's it going out there for the queen raisers?
Not great.
So do you
There
think,
might be, I mean, I don't know, they might make it, but so hard to tell, because they know when they're trying to do this, if the weather is holding up or not. So they definitely monitor and make sure that the queens are mated and start egg laying right before you get them. They're very aware of the weather and potential issues with it. So I can't tell you exactly what that means in terms of the queens that you're going to be getting, but I know that they're all worried about their businesses, right? So they're doing everything they can to make sure that those queens that they send you are going to be still good queens.
Now we have the opportunity.
Keep your fingers crossed.
We have the opportunity to get some Hawaiian queens.
Mm-hmm.
Which
ones?
Oliveras.
Mm-hmm.
They said that they could send some Italians. How well do you think they will do in California? I mean, in our area.
I don't see a reason why they wouldn't do okay. I actually don't know where all of his like genetic stock comes from. I guess they're not supposed to necessarily be shipping stuff into Hawaii, but I mean, I haven't heard anybody say anything negative about the queens coming from Hawaii for here.
Janine, the first year I did beekeeping, I lost my queens. So I panicked and got queens from Hawaii because I didn't want to have a failure. They were really good. I
Yeah.
was really happy with the ones. They were well mated. That
And
was
that
my first year
actually-
beekeeping. I was so happy.
I do think I talked to a woman who does research in Hawaii as well. They have been having some issues with the weather as well. So that's hopefully not going to be terrible this year for them either. But I know everybody is having problems with weather, but you know,
They're having clouds.
yeah, I know. Pray for no clouds, no cloudy days. Okay. Thank you, everyone. I didn't even realize it's 8:30. I gotta go put my kids to sleep if they listen to me. I don't know.
How old are they now?
7.5 and 9.
Oh, those are precious ages. I love that.
Oh, very opinionated, right? I don't know how many of you have kids, but very opinionated and definitely already like, don't kiss me, don't hug me, don't look at
Wow.
me. Oh yeah, you're way too cool for having a mom. Kiss him and hug him in public.
In public, okay.
Yeah.
In public, oh yeah, no, here it's like all over, but in public when they're in front of the school and I drop them off, it's like, don't. I don't exist. That's okay. Okay, well, as I said, good luck. And if you have any questions, let me know. I will try and do my best to answer. And if nothing, I can look it up. If I don't have the answer, I know there's somebody who has researched it. Most likely, not everything, but most likely. Okay, thank you so much.
Thank you very much. Thank you very